One of the most important things that we'll be talking about with the continuous probability distribution, specifically the normal curve, are sampling distributions and estimators. Now, what is a sampling distribution? A sampling distribution is a comprehensive list of every possible sample you could take of a population of a specified size. So these are not necessarily something you'd be completing by hand in the real world because theoretically if you had the population data, that would be the best case scenario. The goal is always to have population data, but it's just downright impractical most of the time. So the sampling distribution of the sample mean, we said, is a comprehensive list of all samples of size n, which can be whatever you want it to be, of a population. Now, with the sampling distribution, the estimators that we use are, if you have a sampling distribution, we use mu sub x bar to denote the mean of the sampling distribution, and this is approximately equal to whatever your population mean is. So if you've set this up correctly, your mean of your sampling distribution should in fact equal the mean of your population. Now, on the other hand, if you wanted to use a standard deviation, we have to approximate that because when you're taking samples, it's never going to necessarily be the same as the population standard deviation. And we do this by taking sigma over square root of n. So let's take a look at an example here. A daycare center has 3 classrooms with 6, 10, and 12 children in each respectively. If samples of size 2, so emphasis here, samples of size 2, are randomly selected with replacement, construct a sampling distribution of sample means. Organize this into a probability distribution. So they're asking us for 2 things here. They also told us it's with replacement. So make a list of samples of size n equals 2. Again, this is something that's very difficult to do unless you have a small population, and we only have a population of size 3. So we could pair 6 with itself because it's with replacement, or we could pair 6 with 10 or 6 with 12. We could pair 10 with itself. We could pair 10 with 6 or 10 with 12. And then the last 3, we could pair 12 with itself. We could pair 12 with 6 or 12 with 10. The sampling distribution of means is saying go ahead and take the mean of each of these samples. So these are all our samples. So what are our means? We get 6 plus 6 is 12 divided by 2 is 6. 6 plus 10 is 16 divided by 2 is 8. And continue this down. So we have 6, 8, 9, 10. Let's see. 8 again. We have 11, 12, 9, and 11. Okay. Now, although they haven't asked us for it, so theoretically, what should the mean of the sampling distribution equal? So this, what is this going to equal? Well, if we add this all up, we get, let's see, if we add it up, we have 84 divided by how many different samples were there? There were 9. And that says that the mean of the sampling distribution is 9.3 approximately. It's 9.3 repeating. How do we know we've done it correctly? I ask again. Well, we know the population, and if we add those 3 things up, our population mean is 28 divided by 3, which, surprise, surprise, is also 9.3. So again, those should equal out to one another. You could repeat this. Let's see if you go ahead, if you get your standard deviation, which is 2.4944. So what is the estimate for standard deviation here? 2.4944 divided by the square root of how many we have, which is 9. So that gives us 0.83. So as you can see, those are very different whether you have your population or your sample, because this is measuring the standard deviation of all of these values, Again, that's very different than it measuring just 3 of them. Now we're asked to construct this and organize it into a probability distribution. Well, this is going to be a discrete probability distribution since we have a finite number of discrete values. So our x's are actually x bars. Then we're going to have p of x for the probability that it occurs. The smallest mean that we have is 6. There's no way to get 7. So 6, 8, 9, 10, 11, and 12. What is the probability of each of these? We have a single 6, so it's 1 out of 9. We have 2 8s, 2 out of 9. We have 2 9s, 2 out of 9 again. There's only one way to get a 10, 2 ways to get an 11, and 1 way to get a 12. So if we've done this correctly, what do these have to add up to? 2, 4, 6, 7, 8. 9 out of 9 is equal to 1. So that would be our probability distribution.